outside of 200 miles. Okay, here we go. Um, boys and girls, boys and girls, boys and girls. Here we go. Now, if you look at this piece right here, which is a decision tree, some of you guys were able to make use of this last sheet regarding parent functions of sine, cosine, tangent, and so forth. And you're able to sketch great graphs and make use of it. I'm telling you, some of you just discarded it, and you're like, I'm going to do this on my own. Fine. But I'm just telling you right now, good luck if you don't know how to use this sheet. You need to learn how to use this in order to be successful on this test. And the people who know how to use this do well. People that don't, you're going to struggle, okay? I will teach you. Do you remember from geometry the following letters? A, so on and so forth. Now, I just want to talk about this for a brief few moments. We're talking about triangle congruence. And within triangle congruence, angle, angle, angle does not show that you have two congruent triangles. Why? Because you could have a 60, 60, 60 angle and another 60, 60, 60 triangle. And are those the exact same size? But are they similar? Yeah, so AAA shows similarity, but it does not show congruence. So if you were given three angles in a triangle, we can't solve it. We've been solving triangles. If they were to give you three angles, say find the sides, you'd say, I can't do it. I have no idea how. You can't just out of nowhere come up with one of the sides. The examples that we've done so far together, okay, last Thursday, we did angle, angle, side, and there was one solution using the law of sines. We also did an angle, side, angle, where there was one solution using the law of sines. Those are the easiest situations to come up with. These are more challenging, okay? And that's what we're going to show you today, is we're going to try some of the ambiguous cases. It takes a while to get through these notes, but your focus is going to be paramount to your success moving forward. Look back at these right here. We did these examples together, correct? So I'm going to draw it. I'm going to draw this is angle A, and this is angle B, and this is angle C. Now, okay, here's the question. Which of the six is this? Is this angle, angle, angle? Is it angle, angle, side? Is it angle, side, angle? Second page. Okay, is everybody in the right spot? Okay, does everybody know what they're doing? Okay, you need to be able to identify which of the six is this. Which one is it? Why is it angle, angle, side? Why is it not angle, side, angle? Yes. Okay, girls, please. These are two angles. The question is the side included or is it not included? So angle, angle, side, and angle, side, angle. This is crucial because 50% of people when I teach this don't remember this. They don't understand it. Watch. Does the side sit between the two angles or does it sit outside the two angles? So therefore, it's angle, angle, side. If the 10 sat there, it's between the angles, so it's angle, side, angle. Do you see the difference? So you have to be able to determine that when you write these things out. Here's another one here, okay? I'll draw this one. We've got, call it A, B, and C. B we'll call 12, C is 27, and A is 10. Which one is that? Angle, angle, side, or angle, side, angle? Angle, side, angle, because the side is included with the two angles. That's the difference. Today, we are setting up something else. And this was one that you guys learned when you were in geometry, and your teachers probably wrote it backwards, but you can't, if you side side angle or angle side side spells a bad word, right? So therefore, we can't use it to show congruence. Well, in trigonometry, we don't talk about trying to show congruence. We talk about whether or not you can solve the triangles with it. And the fact of the matter is, you might be able to, but there's a problem. You might come up with one solution. You might come up with two solutions. You might come up with no solution. So this is the most difficult situation that we're going to talk through today, and you're going to be able to figure it out as long as you follow this sheet. So let us go to this example. Where am I? Law of signs, this is called the ambiguous case. If you end up with side-side angle, you might have it that the opposite leg is shorter and get two solutions. Here's an example. Draw a triangle. Say this is an angle of 40 degrees. And then you're going to have two sides. Is the angle included between those two sides or not? No. So we'll call this, say, 10. And we'll call this other side 9. Watch what happens. I'll only do this once. Okay. See how I have an angle, a side, and a side, or a side-side angle. The angle is not between the two, right? Is the side opposite the angle longer or shorter than the other given side? When all the examples that I gave you on this worksheet, if you look at them, we did some side-side angle situations, but every time I gave them to you, the side opposite the other side was always longer. When it's shorter, you might have two solutions. And here's how you know. Watch this. The 9 could be that, or it could be that. Right? See this triangle, kind of the skinnier one? This triangle a little bit bigger? They both have two sides of 9 and 10 and an angle of 40, don't they? So how do you know which one it is? And in that situation, we have to set up two solutions. One for this triangle and one for that triangle. So you can see that this gives you, whoop, don't do that. This gives you one of the solutions, and then your other triangle, that one will give you another solution. Both of these lengths are 9, and therefore you have two solutions. Here's another situation. You could set up a side-side angle just like we have, where A is 40. This side we'll call 10, and this side we'll call it 1. Okay? That's a no solution. Anybody know why? Well, yeah, but this opposite, look, the opposite side is shorter than the other given side, right? Well, with this one, I was able to make two triangles. Why can't I make two triangles with this one? Because this side is just too darn short. So you might have a no solution scenario where this side is it's just too short. You can't solve it. Okay? So there you have that. Or you might have a one solution situation, which is what I drew for you guys in our last example, or in our examples on Friday. So if this is A and this was 40, and say this is 10, let's say that this opposite side is 15. if you have a triangle where it's, again, side angle, and the opposite side is this shorter or longer than the other given side? It's longer. If you come up with one where it's longer, then you can only get one solution. Because if I swing this on the pendulum, try again, come on. If I swing this on the pendulum, does it make another triangle? No, it does not. And so therefore, you have just one solution. So let's go through a couple of these and see if we can figure them out together. Solve the following triangles by classifying which 5 cases it will be and actually going through and solving them. So I'm going to set up A, B, and C, little a, little b, and little c. What? Okay, so my angle is 42 degrees. And then my side is 22. Side B is 12. Which of the 6 is this? Angle, 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 side, angle, side, side, angle. Which of the 6? Side, angle. Okay, because you have a side, and the angle is not included. What if they would have given me angle C? Then it would have been side, angle, side. Okay, so I have side angles. What you do is you always turn to this sheet, which I told you to take out. You turn to side angle, and you follow the path. Look at what it says. It says, is the side opposite the angle shorter than the other given side, or is the side opposite angle longer than the other given side? It is. And so therefore, if you look, because it's longer, it says there's one solution, use the law of sines. So as I look at my picture, the side opposite A, 22, is longer than 12. So I'm confident that I can solve and that there's just one solution. So let's solve. Sine of 42 over 22 equals sine of B over 12. Okay? So what I'm going to do is I'm going to multiply both sides by 12. 12 times the sine of 42 divided by 22. I get 0.3650. I'm going to round to 4 decimal places. 0.3650 equals the sine of B. If you're going to use decimals to calculate this, you must round out to 4 decimal places, otherwise it won't work. How do I find the angle? That's not my angle. What do? I do sine inverse, and on my calculator, I press second negative, so it takes that previous answer, plugs it in, and you press enter. Before I do that, okay, we got to think about something real quick here. Remember when we were graphing sine and cosine? What was the biggest value sine or cosine could be? Okay, we covered this. You guys know this, okay? Y equals sine of x, okay? What's the vertical shift? None. What's the amplitude? 1. So what was the maximum value you could have? 1. Okay, what's the smallest value you could have? Hey, 1. So here's the deal. Look at what we came up with, because this is going to come up later. We got 0.3650, okay? Can sine have a value of 0.3650? That's between 0 and 1. Can sine have a value between 0 and 1? Yes. So what I'll do is I'll second sine inverse. I get 21.41. So B is 21.41 degrees. Hey, folks, can we put away the cell phone? Like, I get that I'm not that interesting, but then when I try to help you when you don't know the material, it makes it really frustrating. Okay, so now which one can I find? C. So I go 180, I go minus 42 minus 21.41, and I get 116.59. Can I now find side C? How do I do that? Sine of 42 over 22 equals the sine of 116.59 over C. And so what I end up doing is I'll cross multiply here and I'll end up dividing by the sine of 42. Have you guys gotten good with that you're now doing that on your calculator? So you should be there right now. If you're not, come see me so we can figure it out together. But this is kind of the shorter way that people are starting to do it. And then we'll end up dividing by the sine of 42. And you can see that we get 29.40. Let's check the reasonableness of our solutions, okay? As you check the reasonableness of your solutions here, what's my biggest side? C, what's my biggest angle? What's my smallest side? What's my smallest angle? See that? So that works out. So that example is done. Let's try one that works out a little bit differently. I'm going to sketch my triangle. So I've got A, got B, got C. This is 85 degrees. A is 15 and B is 25. So A, B, C, A, B, C. And A is 85 and 15 and B is 25. Okay. Which of the 6 scenarios do I have here? I still have a side-side angle. The angle is not included in between. Once again, if 85 would have been sitting over here at C, then it would be an angle, side angle, and that would be a different, a side angle, side, and that would be a different solution. So I go to my handy-dandy decision tree Mr. Gentz made for me, and I recognize its side-side angle, and I follow it down, and I look, and I have to decide, is the side opposite the angle longer than the other given side, or the side opposite the angle shorter than the other given side? It's shorter. So therefore, you have 2 possibilities. So right now, this is the path that we are down. We're over here, and then we will either be at that spot or at that spot. We either have no solution or we have 2 possible solutions. I'll show you how to determine it. Go back to your notes. Okay. And I set it up. Sine of what? Over equals sine of B over. So like I did before, I'm going to multiply both sides by 25. And I get 25 sine of 85 parentheses divided by, okay, 25 sine of 85 divided by 15, and we get 1.6603 equal to sine of B. Okay, this is the point that everybody gets confused on. Right here, can sine be equal to 1.66? Why? What's the maximum value that sine can have? 1. So because, and it even says on your sheet right here, it says, when solving for the missing angle, if sine of theta is greater than 1, then there is no solution. And watch what happens. Hannah, please. So let's look and solve for this. If you take on your calculator and you go sine inverse of 1.6603, watch what happens to your calculator. This is a domain error. And if you press go to, it'll even tell you what the problem is. It doesn't like that value you plugged in. Sine can't be greater than 1. So this problem no solution. And we are done with that problem. We have one more example today, folks. Let's draw the triangle. Angle A is 20.5, side A is 12, side B is 31. Call this angle B and this angle C. Angle A is 20.5, side A is 12, side B is 31. Which of the six is this? Still a side-side angle. I go to my decision tree, and it says, is the side opposite the angle shorter than the other given side, or is it longer than the other given side? Side opposite the angle is 12. That's shorter than the other given side. So therefore, you have one of two possibilities. When solving for your triangle, you might get a no solution, or you might get two. Let's set it up. Sine of 20.5 divided by 12 is equal to sine of. Okay, we're going to cross multiply and solve just like we did last time. I get 31 sine of 20.5 divided by 12. Can sine have a value of 0.90? So therefore, as it says in your decision tree, when solving for the missing angle, if sine of theta is less than 1, then there are two solutions. At this point, set up two possible triangles. We have a triangle right here, and we're going to set up another one. First, I'm going to write this down, 0.9047, okay, is equal to the sine of B. At this point right here, and this is probably the biggest mistake that people make, is they don't set up the second triangle right now. Your notes say to set it up right now, so that's what we do. I keep these the same, 20.5. This one, 12. This one, 31. All the rest of the pieces, B, C, and then side C, are going to be different. How do I find this angle? What do I do? Sine inverse of the answer. And we get 64.78. So I write here 64.78. But that would be for triangle 1. Do you remember when I made the picture at the very beginning, you guys? And we looked at this picture right here, and I said, you've got the green triangle and the red triangle. We just found this angle right here for the red triangle. So the second triangle would be this angle here for the green triangle. Here's how we find that angle. It's very, very simple. The first one we found was 64.78. We find the other one over here by doing 180 minus 64.78, 115.22. I have my two different angle B's. Now I solve them separately. Given this is 20.5 and this is 64.78, can you find angle C? How do you do that? Minus from 180. So let's do that. 180 minus 64.78 minus 20.5. And I get 94.72. Oh. 4.72. Okay. Could I find side C now? How would you find side C? Sine of 20.5 over what? 12 equals sine of 94.72 over what? C. We solve for that. 12 sine of 94.72. 12 sine of 94.72. Okay, we're almost done. 34.15. You don't have assignment today, folks. We just got to get through this last piece. That's triangle 1. We're done with triangle 1. We haven't solved triangle 2. Can I find angle C for triangle 2? How? Minus from 180. So 180 minus 115.22 minus 20.5 is 44.28. Can you then find side C? Set up the law of sines. Sine of 20.5 over what? 12 equals the sine of what? 44.28 over C. We solve that. 12 sine of 44.28 divided by a sine of 20.5. And we get 2392. That's triangle 2. That's the hardest part of this unit. If you could do that, you could get an A on the test. Tomorrow we pick up with that. You guys will be given a lot of time to practice tomorrow in class. But we're going to start out with 2 checkpoints to see if we can get through those pieces, okay? Enjoy your night of no homework. If you didn't finish up Fridays, get working on that.